by some treatment methods of the water. These treatment methods may be internal methods or it may be external methods. Now, internal treatment methods means prior to boiler feed, we add some chemicals in the feed water and convert them into either the softer water or water which may be used without any trouble. The first internal treatment method is phosphate conditioning. Here, the removal of scale or sludge causing problem can happen by adding phosphate. Small amount of phosphate ion PO4 3- ion are added which may cause precipitation of calcium ions, and thus scale due to calcium sulfate etc. may be minimized. The phosphate ions are chosen depending on the pH conditions of the boiler. Here in the equation you can see sodium phosphate react with calcium carbonate, convert into, now the calcium carbonate is a scale forming compound, but it can get converted into calcium phosphate which can be removed by blow down operation, and the scale formation can be avoided, plus sodium carbonate. These are the chemical deaeration method that we have already talked about. You can see oxygen can be removed from sodium sulfate by adding sodium sulfate, by adding sodium sulfide, by adding hydrogen etc. Carbon dioxide can be removed from ammonia, addition of ammonia. Carbon dioxide may react with ammonia and form ammonium carbonate. Now, besides phosphate conditioning, we can carry out colloidal conditioning. Colloidal conditioning, we add some substances which form colloids, and these colloids are trapped around the scale or sludge formation compounds and keep them apart from each other, like kerosene, tannin, starch etc. They are added. These are coated over the scale forming particles and avoid formation of scale. The sludge thus formed can be removed by blow down operation. The third internal treatment method is carbonate conditioning. Carbonate conditioning, in this we add sodium carbonate, though it may lead to the formation of caustic embrittlement later on, but it can be used for removal of scale due to calcium sulfate. Calcium sulfate react with sodium carbonate, convert it into CaSO3, which is comparatively a softer scale. CaSO4 may lead to the formation of harder scale which can't be removed even with chisel and hammer, but CaSO3 is a softer scale. So use of soda ash or Na2CO3 convert it into CaSO3 which can be removed by blow down operation. This is basically used in low pressure boilers. See the reaction. This is the chamber consisting sodium carbonate or soda ash. These are the carbonate ion, these are sodium ions. This is the chamber consisting hard water. This is hard water. Now when these two are mixed, माने hard water is mixed with sodium carbonate solution, then these Ca2 plus may combine with CO3 2- and may form CaCO3. Thus calcium sulfate or the other hard scale may be avoided. So in this manner carbonate conditioning is done in the boiler. Calgon conditioning. Calgon is the chemical name of a compound known as sodium hexametaphosphate Na2PO3(6). In this conditioning or in this treatment method, calgon is added in the hard water and the scale forming salts are converted into soluble complexes, and thus scale formation can be prevented. Here you can see in this particular reaction, this is calgon, sodium hexametaphosphate. it ionizes to give 2Na plus ion and hexametaphosphate anion. This hexametaphosphate anion reacts with scale forming compound like calcium sulfate and form soluble complex of calcium hexametaphosphate along with the formation of sodium sulfate. So the scale formation due to this calcium sulfate can be avoided as it gets converted into soluble complex. The other two methods, internal treatment methods, are radioactive conditioning and electrical conditioning. In radioactive conditioning, some radioactive tablets are added in the boiler which emit some radioactive radiations, and these radioactive radiation splits the scale formation compounds particles into small particles. And in electrical conditioning, mercury bulbs are placed in the boiler, and by electric discharge scale formation can be prevented. External treatment method or water softening method. Till now what we have discussed were internal treatment method which are performed within the boiler only. We add all these chemicals in the boiler, but external treatment method means prior to boiler feed we carry out some process to convert hard water into soft water, and that's why these external treatment methods are also known as water softening methods. These are namely three methods: lime soda process, zeolite process and ion exchange process as shown, and we will be dealing one by one with all these processes: lime soda, zeolite and ion exchange process. First of all, we will be dealing all these methods in terms of their principle, in terms of their process, what are the stoichiometry, if the numerical problem or chemical calculation is to be done, then that also will be including, and advantages and disadvantages of these methods. First of all, let us take lime soda method. Lime soda method is based on the principle of converting hardness causing soluble salts into insoluble salts. Hardness is due to soluble salts basically of calcium, magnesium, etc. If we carry out some chemical reaction by which all these soluble salts can be converted into insoluble salts, then and these insoluble salts are filtered and removed, then we can get soft water. So the principle here is hardness causing salts react with calculated amount of lime and soda, that is soda S, sodium carbonate, and convert them into insoluble salts which are filtered and removed to give soft water. On this principle, lime soda method works. How these convert the hardness causing salts into insoluble form? You can see some amount of lime and soda may react with some other chemicals also. First let us see, this is calcium bicarbonate which causes temporary hardness. Lime reacts with this and convert into CaCO3 which is insoluble. Magnesium bicarbonate, again temporary hardness causing, lime reacts with this and convert it into CaCO3 and MgCO3. Now this MgCO3 again reacts with lime and convert it into MgOH whole twice. Means magnesium bicarbonate requires 2 moles of lime. 2 L are required for removal of magnesium bicarbonate. Magnesium sulfate reacts with lime and gets converted into magnesium hydroxide which is insoluble. Magnesium chloride reacts with lime and converts into magnesium hydroxide, but along with this it adds calcium sulfate and calcium chloride also. These calcium sulfate and calcium chloride are further requiring soda for removal. So on the basis of all these chemical reaction, we first find out what amount of lime and soda is required for removal of all these salts. Here you can see lime remove the temporary hardness of calcium and magnesium. Lime removes the permanent magnesium hardness, but along with that it produces these salts. And lime remove dissolved iron and aluminium salts. It is also used for removal of this. It removes free mineral acids, namely this and this. It removes carbon dioxide and H2S. Soda removes all soluble calcium permanent hardness. So from all these chemical reaction and their stoichiometry, we can come to know what amount of lime and soda is required for removal of these soluble salts in the insoluble form. And these are the few rules that we need to keep in mind while dealing with the lime and soda calculation. On the basis of this, we calculate the amount of lime and soda required for the softening, and we convert it into a formula. Lime requirement for softening is given by this formula: 74, which is the molecular mass of lime, divided by 100. Temporary hardness, TH stands for temporary hardness of calcium, plus 2 into temporary hardness of magnesium, plus permanent hardness of magnesium, iron, aluminium, plus carbon dioxide, plus H plus, etc., minus sodium aluminate, divided by 2. All these must be in CaCO3 equivalent. As we have earlier discussed, hardness is expressed in terms of CaCO3 equivalent. So first we convert it into CaCO3 equivalent. This is the equation for soda requirement. What amount of soda is required? 106 by 100. Permanent hardness, pH stands for permanent hardness of calcium, magnesium, iron, aluminium, H plus minus, HCO3 minus, into volume of water, the amount of water that is needed to be softened. So in this manner, we first calculate amount of lime and soda which are required. Let us see with the help of a problem. The problem say calculate the amount of lime required for softening 5000 liter of hard water containing 72 gram of ppm milligram per liter of magnesium sulfate. Now first of all, what we need to do, we always list out the given data. We have listed here magnesium sulfate, 72 ppm hardness, water quantity to be softened is 5000 liter, and molecular weight of magnesium sulfate given is 120. And then we convert it into CaCO3 equivalent, which is done by multiplying 72 with the multiplication factor, and multiplication factor is nothing but 100 for CaCO3 molecular mass and 120 for magnesium sulfate molecular mass. It gives you 60, means 60 ppm in terms of CaCO3 equivalent hardness of magnesium sulfate is there. And then lime requirement would be 74 by 100 into hardness due to MgSO4 in terms of CaCO3 into volume of water, and the amount given is 222 gram of lime is required for softening of hard water. So in this manner we can convert hard water into soft water by using lime and soda, but the thing that we keep in mind that it should be in a proper amount, in a calculated amount, as we have seen from these equation. Now in the next we will be talking about process, cold lime soda, hot lime soda process, and the other methods of softening. Thank you till now.